back. Let's take a look at a third method for IXL T.10 that you can use in very special situations. This method for looking at surface area and volume, it's a shortcut that makes problems so much faster, but the catch is it only works when all the sides are changed. So no matter whether you're working with volume or working with the surface area, this method, all sides must change by the same amount. And they must change by the same amount. But I'll leave that little part off and trust that you can pick that up on your own. So here, taking a look at this problem, if the side lengths are tripled, so all of the sides are being changed, specifically they're being multiplied by 3, then which of the following statements about the surface area will be true? So here, I want you to pause a moment, think back to when you have to write down the units. How do you measure units if you are measuring by area? An area, think about it, it's measured in unit squares. We want to know how many squares of whatever size would fit on that surface. And so here it's in units squared, and that squared is going to play a big part, because what we're going to do is, if the area is being squared and all the sides are changing, what we can do is we can come over to the factor that they're changing by. So here it's changing by 3, and we're going to square that. So 3 squared is 9. And so our new surface area is going to be 9 to the original 1. So if you were writing it as a ratio, it would be 9 to 1. Or sometimes they write it as 9 times bigger, or just plain 9 times, which ends up being the case for this IXL. So I'm going to hopefully scroll down, find the answer where it says it's 9 times bigger, and there we go. So that's super, super fast, but remember, it only works if all of what we call the linear measurements, so length, width, and height, or the radius and the height, the radius and the slant height, etc., all the linear measurements have to change. So in this problem, both the radius and the slant height are doubled, so because it happens for both, we can use our shortcut method. So doubled means they're times 2, then which of the following statements about the surface area will be true? Surface area is units squared, so we're going to take that squared, come over here, square our amount. 2 squared is 4. That means it'll be 4 times bigger, or a ratio of 4 to 1. Then scroll down, find the ratio is 4 to 1, and we're done. So much quicker than the old ones, but make sure that linear measurement is, all of them are being changed. Here we've got a sphere. The radius is the only linear measurement, so the radius is tripled, which means it's times 3. Then which of the following statements about the volume is true? Here, volume is measured in units cubed. So if it's in units cubed, we're going to come over here, we're going to cube that. Remember, the exponent tells you how many times to multiply, so we'll do 3 times 3 times 3, or you could just punch it in your calculator, and 3 times 3 times 3 is 27. So it'll be 27 times bigger. Woo! That was really quick. So hopefully you're liking this method. But whoops, here's a problem where it doesn't work. So in this problem, only the height is quadrupled. So only one thing. Now you have to go back to method 1, which is you have to actually calculate it out by hand. So we're trying to find the volume, so we'll take the volume of the new shape, divided by the volume of the old shape. So here, the new shape, we're quadrupling the height. So we take 3 times 4 equals 12. So in our length times width times height. For the new shape, we've got 7 times 6 times 12. And then for our old shape, excuse me, we've got all the original numbers, so 7 times 6 times 3. And we can go through and calculate that. Fun fact, if you want, you can cross out what's the same anyway if you don't want to use a calculator, which I don't want to use a calculator right now. I've got 7s cancel out, 6s cancel out, and we're left with 12 over 3. So you can just divide these two. And 12 divided by 3 is 4. And so that'll be 4 times bigger, or 4 to 1. So just recognize if only one thing changes, then you have to go through and you have to plug in the numbers and figure it out. I'll do one last example just so you can figure it out. Here they give us a fraction, which we've not seen that in any of the videos, but same methods still apply. So with this, both the radius and the slant height are halved. So that means we're dividing them. Halved is like a fraction 1 over 2. And for them, this method, I recommend you write it as a fraction. And so they're being halved. Then which of the following statements about the surface area is true? Since it's both of them, you can look at it, say, hey, surface area is units squared. And so because it's squared, we can come over here and square this. Remember, if you're squaring a fraction, you can square the numerator and denominator separately. So 1 squared, or 1 times 1 is still 1. 2 squared is 4. And so it would be 1/4 of the size, or it would be, sometimes you might see it written like, it might say 1/4 of the area, or it could say 4 times smaller. So you have to kind of watch out for the tricky wording that IXL might show at you. And of course, it might also write it as a ratio, which, remember, just the top number comes first, so it could be 1 to 4. In this case, looking down at our options, it says the new surface area will be 1/4 of the old surface area. So there's some different examples. Go through, try those out. I really like this method, but with that method, focusing on units squared, or with volume units cubed, which is what you would have to do in this case, make sure